I am Professor Antonio S. Marahas, and this is Digital Technique Fundamental. Binary division. So we have here a table. 0 divided by 0 is 0. 1 divided by 1 is 1. Okay, so example, let's say we have a decimal number which is 25 of base 10. We want it divided by 5 of base 10. So we want to perform the binary division of these particular decimal numbers. So again, all we have to do is to convert these decimal numbers into its binary equivalent. So for 25, we have a series of 1, 1, 2, 4, 8, 16. So for 25, you have 1, 24, 0, 0, 25. Okay? So you have 1, 1, 0, 0, 1 of base 2 divided by 5. What is 5? 1, 0, 1 of base 2. Okay? So the first step here is to determine which of the number inside, the 3-digit number, for example, 1, 2, 3 here, this one here, determine if this one here is bigger than the number outside. No? For example, you have 1, 0, 1, that is 3-digit. You compare it with 1, 1, 0. Which one is bigger? If this one here is bigger, then you start your answer here on the 3rd digit of the number. No? So in this case, this is what? 1, 2, 4. So you have 4 plus 2 is 6. And this one here is 5. So 6 here is bigger than 5. So you start with 1 here. So you have 1, 0, 1. Okay? So you multiply here 1 with 1, 0, 1. So you have 1, 0, 1. Then subtract. Okay? 0 minus 1 is 1. This becomes 0. Okay? Stop because this is 1. You stop borrowing. Then you have 0 minus 0 is 0. 1 minus 1 is 0. Bring down 0. 1, 0 is less than 1, 0, 1. So this is 0. Bring down 1. You have 1. 1 times 1, 0, 1 is 1, 0, 1. Subtract, you have 0, 0, 0. Okay? So base 2. So in other words, this one here is your answer, which is actually equal to 5. No? Because 25 divided by 5 is 25. I mean, 25 divided by 5 is 5. Okay? Correction. So, this one here now is your answer. Okay. Let's have another example. Let's say 1110.01 of base 2. We want this divided by 1, 0, 0 of base 2. Okay? So again, the first step that you should do is to determine the first digit here if this is bigger than the digit here outside. So since 1, 1 is 7, bigger than 1, 0, 0, which is I believe 4, then you start putting a 1 here on the 3rd digit of the number. 1 times 1, 0, 0 is 1, 0, 0. Okay? Then subtract. You have 1, 1, 0. Bring down 0. 1, 1, 0 is bigger than 1, 0, 1, 0, 0. So you have 1 here. 1, 0, 0. Subtract. You have 0, 1, 0. Okay? Then, you put the binary point there. Then you bring down 0. Which is actually equivalent to 1. Okay? Then you have 1, 0, 0. Subtract, you have 0, 0, 0. Bring down 1. Okay? This one here is less than this one, so you have 0. Okay? Then you add another 0 here. Bring down 0. Now 1, 0 is still less than 1, 0, 0. So you add, this is 0, you add another 0. Bring down 0 again. Then you have 1. You have 1, 0, 0. Subtract 0, 0, 0 of base 2. So that will now be your final answer. Okay? Now, in division, in binary division, just limit your here up to 4 digit after a binary point. No? Going to the right, you have 4 bits only. That's how division of binary division is. That is how binary division is performed. Okay, so let's have this as our example. Now, again, to divide this number with this number, the first step is to determine the first 3 digit of the number inside, no? This one, which is 101, and compare it with the number outside, which is 110. Which one is bigger? I believe that this one here is bigger because this is 6, and this one here is only 5. So, you have to consider, since this one here is smaller than the number outside, so you have to consider the 4th digit. So that this number here inside becomes bigger than the number here outside. Okay? So, basically, this becomes 1. So, 1 times 110, you have 110 here. You subtract. Okay? 1 minus 0 is 1. 1 minus 1 is 0. 0 minus 1 is 1. This becomes 0. Bring down 0. Now, 101 is smaller than 110. Down 0. Okay? So you have 1. This is 3 digits. So this one here is bigger than the number here. So you have 1. You have 110. Subtract again. You have 0. 1 minus 1 is 0. 0 minus 1 again is 1. And this becomes 0. Bring down 0. Okay? Now, since 100 is less than 110, bring down 1. So you have here 1. Then, 110. Again, subtract. 1 minus 0 is 1. 0 minus 1 is 1 again. This becomes 1. This becomes 0. Borrowing when you encounter a 1. Then, continue subtracting. 1 minus 1 is 0. Bring down 0. Okay? Then you have here the binary point. Now, since 1 is less than 110, bring down 1. So, 111 is greater than 110. So, you have here 1 again. So, you have 110. Subtract. So, you have 100. Then, bring down 0. 10 is less than 110. So, this is therefore 0. Then, you add 0. Bring down 0. And 100 again is less than 110. So, that means that this is 0. And then, you add another 0. Bring down 0. Okay? Now, 100 is now bigger than 110. So, this becomes 1. So, you have 110. Subtract. You have 0. 0 minus 1 is 1. This becomes 1. This becomes 0. You have 1 minus 1 is 0. Bring down 0. Then, you have already 4 digit here. 1, 2, 3, 4. So, you can stop your series of division. So, this becomes your final answer. Okay? So, you have 111.1001 of base 2. So, if you want to do the checking, all you have to do is to convert this number here into its decimal number equivalent, and this one here into its decimal number equivalent. Then you divide. Then you try to find out if the answer after dividing these two here in decimal equivalent, if it is equivalent to 111.1001 or approximately equal to. Okay? So that is how you do the binary division. Again, you consider first the 3-digit inside and compare it on the 3-digit outside. If the 3-digit inside is smaller than the 3-digit outside, then you have to consider the 4th digit. If not, then you start with the 3rd digit of the number inside the division sign.